Hello everyone. We are going to discuss about what is 1,3 dipole radiation. Before going to discussing about this 1,3 dipole radiation, we want to know what is 1,3 dipole, what is dipolophile. Okay, first we look at this one. What is 1,3 dipole? A 1,3 dipole bears a positive and negative charge distributor over 3 atoms and has 4 pi electrons. Just look at this one. In this example, take nitron as example. In this nitron, a positive charge is present on the nitrogen atom and a negative charge on the oxygen atoms. And when the pi electrons in between the carbon and nitrogen atoms is donated to the carbon atom, to the nitrogen atom. The positive charge of the nitrogen atom get neutralized and the carbon atom get positive charge. So here 3 charges are distributed over, that is positive and negative charges are distributed over 3 atoms. Hope you understand. That is in between the carbon atom and the nitrogen atom a pi bond is present, and these pi electrons are transferred to the nitrogen atoms. So the nitrogen atoms that already has a positive charge. So when these electrons are coming, its positive charge get neutralized, and at the same time the carbon atom which is donating the its electron to the nitrogen atom, so the carbon atom gets a positive charge. So there is positive charge and negative charge on the oxygen atom at this time. So here the positive and negative charges are distributed over these 3 electrons, these 3 atoms, carbon, nitrogen, oxygen atoms. Such molecules are known as 1,3 dipole. Here totally 4 pi electrons are present. So a 1,3 dipole has 4 pi electrons. These are also known as lids that we have already studied in the former classes. What is lids? And the most common atoms incorporated are carbon and oxygen atoms in the 1,3 dipole. Now we are going to look what is dipolophile. A dipolophile, it's a reactive alkene moiety containing 2 pi electrons. It's a alkene which is reactive moiety that contains 2 pi electrons. In the 1,3 dipole there is 4 pi electrons. But in dipolophile they have 2 pi electrons. Example, alpha beta unsaturated aldehydes, ketones, esters, allylic alcohols, etc. Just take a look at these examples. Dipolar addition. 1,3 dipolar addition is similar to Diels-Alder reaction. In Diels-Alder reaction, it is the reaction between a diene and a dienophile. While here in 1,3 dipolar addition, it is a reaction between a 1,3 dipole and dipolophile. Then thermal 4+2 cycle addition reaction. It's a type of 4+2 cycle addition reaction. Then here 2 components are involved. Then 1,3 dipole has 4 pi component and dipolophile has 2 pi component. That we have already discussed. Then heterocyclic 5-membered ring system is a product. By the reaction in between 1,3 dipole and dipolophile, a 5-membered ring system is formed. Now we are going to discuss about what its mechanism is operating. Here the first ABC, it's the 1,3 dipole. That is the charges, positive negative charges is distributed about 3 atoms ABC. In the അടിയിലുള്ളത് ഡൈപോളറോഫൈൽ. ഇതിൽ റിയാക്ഷൻ എങ്ങനെ നടക്കുന്നത് വെച്ചാൽ the pi bond is broken between the B and C, and the C electrons are the pi electrons are shifted to the B molecule. That is here the positive charge is neutralized and C get a positive charge because its electrons are the pi electrons belonging to C is transferred to B. Now the pi electrons between E and D is broken and the electrons are transferred to D. So D get a negative charge and E get a positive charge. he get a positive charge. So now a bond is formed between this positive and negative and also this positive and negative charged atoms, and thus the final product A, B, C, D, E. Now moving to an example. Look at this. The above compound, this is the 1,3 dipole and this is the dipolophile. Here as we see in the example, here the positive, it has a positive, the nitrogen has a positive charge and oxygen has a negative charge. And now the pi electrons are shifted from this carbon atom to this nitrogen atoms. Thus this carbon atom has got a positive charge and the charge positive charge on nitrogen atom is get neutralized. Now this pi bond and the dipolophile is broken and electrons are shifted towards this side and this side get a positive charge and bond is formed between this positive charge and negative charge and this positive charge and negative charge. That's the final product. It is an intermediate and we get the final product as like this. Nextly, the 1,3 dipolar addition using molecular orbital approach. നമ്മൾ പറഞ്ഞു ഇവിടെ 1,3 ഡൈപോൾ എന്ന് പറഞ്ഞാൽ എന്താ 1,3 ഡൈപോൾ എന്ന് പറഞ്ഞാൽ ഒരു ഡബിൾ ബോണ്ടും ഉണ്ട്, പിന്നെ അലൈലിക് പൊസിഷനിൽ ഒരു നെഗറ്റീവ് ചാർജ് ഉണ്ട്. അതായത് ഒരു അലൈൽ മോളിക്യൂളായിട്ട് നമുക്ക് ഇതിനെ കമ്പയർ ചെയ്യാൻ പറ്റും. സോ ഇതിൻ്റെ നമ്മൾ 1,3 ഡൈപോൾ അഡീഷൻ്റെ മോളിക്കുലർ അപ്രോച്ച് പറയുന്ന സമയത്ത് നമുക്കതിനെന്തായിട്ട് ഒരു അലൈൽ ആനിയോണായിട്ട് കമ്പയർ ചെയ്യാൻ പറ്റും. അങ്ങനെയാണ് നമ്മൾ മോളിക്കുലർ ഓർബിറ്റൽ ഡയഗ്രം എക്സ്പ്ലെയിൻ ചെയ്യുന്നത്. അപ്പോൾ ഇതെന്ന് പറയുന്നത് ഡൈപോളറോഫൈലിൻ്റെ ഓർബിറ്റലും ഇതെന്ന് പറയുന്നത് നമ്മൾ 1,3 ഡൈപോളിൻ്റെ ഓർബിറ്റലാണ്. അതായത് 1,3 ഡൈപോളിന് 4 പൈ ഇലക്ട്രോൺസ്, പിന്നെ ഡൈപോളറോഫൈലിന് 2 പൈ ഇലക്ട്രോൺസ്. അപ്പോൾ ഇതിൽ ഹോമോ എന്ന് പറഞ്ഞാൽ എന്താ, ഹയസ്റ്റ് ഒക്കുപ്പൈഡ് മോളിക്കുലർ ഓർബിറ്റൽ. ഇപ്പോൾ 1,3 ഡൈപോളിൻ്റെ കേസിൽ ഹയസ്റ്റ് ഒക്കുപ്പൈഡ് മോളിക്കുലർ ഓർബിറ്റൽ എന്ന് പറയുന്നത് ഇതാണ്. അപ്പോൾ ഇതാണ് ഇതിൻ്റെ ഹോമോ. ലൂമോ എന്ന് പറഞ്ഞാൽ ലോവസ്റ്റ് അൺഒക്കുപ്പൈഡ് മോളിക്കുലർ ഓർബിറ്റൽ. അപ്പോൾ 1,3 ഡൈപോളിൻ്റെ ലൂമോ എന്ന് പറയുന്നത് ഇതും. പിന്നെ ഡൈപോളറോഫൈലിൻ്റെ കേസിൽ ഹയസ്റ്റ് ഒക്കുപ്പൈഡ് മോളിക്കുലർ ഓർബിറ്റൽ പറയുന്നത് ഇതും, ലോവസ്റ്റ് അൺഒക്കുപ്പൈഡ് മോളിക്കുലർ ഓർബിറ്റൽ പറയുന്നത് ഇതുമാണ്. അപ്പോൾ ഇവിടെ നമുക്ക് 2 കേസാണ് ഉള്ളത്. അതായത് ഇവിടെ ഈ ലോവസ്റ്റ് ലൂമോ ഓഫ് ഡൈപോളറോഫൈലും പിന്നെ ലൂമോ ഓഫ് ഡൈപോളറോഫൈലും ഹോമോ ഓഫ് 1,3 ഡൈപോളും തമ്മിൽ റിയാക്ഷൻ നടക്കാം. അതായത് ഇവർ രണ്ടും തമ്മിൽ റിയാക്ഷൻ നടക്കാം, കമ്പൈൻ ചെയ്യാം. അല്ലാന്നുണ്ടെങ്കിൽ ലൂമോ ഓഫ് 1,3 ഡൈപോളും ഹോമോ ഓഫ് ഡൈപോളറോഫൈലും തമ്മിൽ കമ്പൈൻ ചെയ്യാം. അങ്ങനെ 2 പോസിബിലിറ്റി ഉണ്ട്. അപ്പം നമ്മൾ പറഞ്ഞ ഈ കേസ് എന്ന് പറയുന്നത് ഇതിൽ ഒരു സബ്സ്റ്റിറ്റ്യുവൻസും അറ്റാച്ച് ചെയ്യാത്ത സമയത്താണ്. ഇനി ഇതിൽ ഏതെങ്കിലും ഒരു സബ്സ്റ്റിറ്റ്യുവൻറ്റ് ഡൈപോളറോഫൈൽ അറ്റാച്ച് ചെയ്താൽ എന്താണ് മോളിക്കുലർ ഓർബിറ്റൽ ഡയഗ്രാം വരിക എന്നുള്ളതാണ്. ഇപ്പോൾ ഫസ്റ്റ് കേസ് എന്ന് പറയുന്നത് 2 കേസ് ഉണ്ട്. ഫസ്റ്റ് കേസ് എന്ന് പറയുന്നത് വെൻ ഡൈപോളറോഫൈൽ ഈസ് ഇലക്ട്രോൺ റിച്ച്. ഡൈപോളറോഫൈൽ ഇലക്ട്രോൺ റിച്ച് ആവുന്നത് ഏത് സമയത്താണ്? എ ഡൈപോളറോഫൈൽ ഈസ് ഇലക്ട്രോൺ റിച്ച് വെൻ electron donating groups are present. When electron donating groups are present, they donate electrons to dipolorophile, so they become electron rich. So the when this is dipolorophile orbital for dipolorophile, so here the highest occupied molecular orbital and it is the lowest unoccupied molecular orbital. So the energy of highest occupied molecular orbital increases and the energy gap between the highest occupied molecular orbital of dipolorophile and lowest unoccupied molecular orbital of 1,3 dipole is less. That is the energy gap between this is less compared to the lowest and molecular orbital of dipolar of oil, and the highest and molecular orbital of the 1,3 dipolar, that is this one. That is, the energy gap between this one is less than energy gap between this one, that we can see from this picture clearly. So they will form like this. But in next case പറയുമ്പോൾ കേസ് ടൂവിൽ ഇവിടെ when dipolar of oil is electron deficient when dipolar of oil is electron deficient when electron withdrawing groups are present. That is, this is our dipolar of oil. Electron withdrawing groups present ചെയ്യുമ്പം അവിടെ electron deficient ആയിരിക്കും dipolar of oil. And this molecular orbital diagram is such a condition. Here we can clearly see that the LUMO of dipolar of oil and the HOMO of 1,3 dipole is close in energy. So there is small energy gap between them, while compared to the HOMO of dipolar of oil and the LUMO of 1,3 dipole, that we can clearly watch from this. So the overlap in the case of this type of 1,3 dipolar addition, that is when an electron withdrawing group is present in the dipolar of oil, the overlap is in between the LUMO of 1,3 dipolar of oil and the HOMO of 1,3 dipole will take place. Now moving to the regioselectivity of 1,3 dipolar addition. Here we have two cases. This is the first case, that is when electron donating group is attached to the dipolar of oil, and this is the case 2. This is the case 2 when electron withdrawing group is attached to the dipolar of oil. First we discuss about the when case 1. In the case 1, here this is a 1,3 dipole. This is a 1,3 dipole and this is a 1,3 dipolar of oil. In the 1,3 dipole, the pi electrons are donated to the nitrogen atoms and the positive charges get neutralized, and this anti-nitrogen atom get a positive charge. That is in here. Here in the dipolar of oil. The dipolar of oil, here is a electron donating group at the end of this dipolar of oil. That is, we can draw it here. Electron donating group. But electron donating group, these electron donating groups will pull the electrons away from the donating group, that is in this direction. So this pi bond at this end, they will get a negative charge, partial negative charge, and this carbon atom get a partial positive charge. So that is we seen here, this negative charge, this side has a negative charge and this side has positive charge. So this negative end will bond with this positive charged nitrogen atom, and this positive charged end will bond with the negative side of the atom, that is in between this side. So the product is formed, that is we seen here. In this, the regioselectivity, the electron donating group is present at the carbon atom near to the carbon atom, CH2 group. You can clearly understand the difference when we discuss the case 2. So moving to case 2, here look at this. This is a 1,3 dipole and this is a 1,3 dipolar of oil. In the 1,3 dipole, as we see all these videos, the positive charge will get neutralized and here a positive charge is generated, that is this one. And in the case of the dipolar of oil, here electron withdrawing group is present at this end. Electron withdrawing group. Electron withdrawing groups will pull the electrons, withdrawing group. So electron withdrawing groups will pull the electrons towards its side. This is in this side. So this end will have a positive charge and this end will feel a negative charge. Thus that is we seen here a negative charge is here, a positive charge is here. So the bond is formed in between this negative side and this positive side, and this positive side and this negative side, that we seen here. This is the product. You can see clearly here. The electron withdrawing group, the substituent is at the side of the carbon atom near to the nitrogen atom. In the former case, in this case, now compare these two. In this case, the substituent is near on the carbon atom near to the nitrogen atom, while in the first case, the electron withdrawing group, the substituent is at the carbon atom near to carbon CH2 group. Okay, I hope you will understand it clearly. And thank you.